Hello, so today we will learn about how to find the feasible region of an LPP. So you must remember that the feasible region only depends on the constraint and the non-negative conditions. It does not depend on the objective function. That is why over here, let the objective function be anything. So we are having these three constraints and we are having these two non-negative conditions. You should also remember that the graphical method can only be used when there are only two number of variables, so that we can use a 2D graph. Okay, for three variables, you will have to use simplex method. Okay, so let's see. Remember that, first of all, if you have to find the feasible region, you will have to convert each constraint into an equality first. Okay, so that we will get lines. Okay, so if you convert this one into an equality, you can actually divide the whole thing by 18. So you will be getting x1 by 3. Okay, I will use a black pen for this. x1 by 3 plus x2 by 3. Sorry, x1 by 2 plus x2 by 3 equal to 1. So this is the first inequality. The second inequality, you cannot divide the whole thing by 0. Okay, so that is why we will leave it as it is. I will be using a red pen for this. Okay, but we have converted it into an equality nonetheless. And this third inequality, okay, it will be less than or equal to 6. So that is why, okay, convert it into an equality, divide the whole thing by 6. You will be getting x1 by 3 plus x2 by 2 equal to 1. Okay, so now that we have converted them into lines, similarly for these two, okay, x1 equal to 0 and x2 equal to 0. You should remember that if x1 is positive and x2 is positive, so that is why these two things, they represent the first quadrant. Okay, so the feasible region, it cannot be anywhere. It cannot be in the second, third or fourth quadrant, because these two non-negative conditions implies both the coordinates are positive or 0. So that is why if the feasible region should exist, it should be over here in the first quadrant. Okay, so if it is less than 0 and x2 is greater than 0, then you will be having it in the second quadrant. You will be having it in the fourth quadrant. Okay, which one? Okay, x1 is okay in the second quadrant actually. Okay, but x1 is negative and x2 is positive, so you will be having it in the second quadrant. Okay, but let us stick with our original example where both of them are greater or equal to 0. That is why in the first quadrant. Okay, now that after converting them into equalities, you will plot these lines. Okay, so that is exactly what I had done over here. I had plotted these three lines, okay, in the graph paper. x1 by 2 plus x2 by 3, okay, which is this line. x1 minus 3 equal to 0, it is this line. x1 by 3 plus x2 by 2 equal to 1, which is this line. Okay, so, and also you will need these two lines, x1 equal to 0 and x2 equal to 0. That one can be easily done. So this one, it is the line, this y-axis, it is the line x1 equal to 0, and this one, it is the line x2 equal to 0. Okay, so after plotting the lines, now you forget about these equalities. Okay, these equalities are only needed for you to plot these lines. But after plotting the lines, you will now come back to these inequalities that we are having. So, but first things first, you need to know that a line, okay, if you take this line, it divides this plane into two parts, this side and this side. Similarly, this line, it divides the plane into this side and this side. This line, it divides the plane into two sides, which is this side and this side. So you need to keep that in mind. Okay, now let us just concentrate. Each inequality will give you a region. Okay, each inequality will give you a different region. So let us just first take a look at the region given by the first inequality. Okay, so the first inequality, it is related to which line? The black one. It is related to this line. So you need to look only at this line when considering the region of this first inequality. Okay, so now what we will do? So this region, it will be either this whole thing or this whole thing right here. We just need to know which side will it represent. Okay, so for that, what we will do, okay, just put 0, 0. Put x1 equal to 0 and x2 equal to 0 here. Okay, we can do that since the right hand side is not 0. Okay, if the right hand side is not 0, just put 0, 0. So when you put x1 equal to 0 and x2 equal to 0, this inequality, will it be satisfied or not? 0, you will be getting 0 is less than 18. So it is satisfied. So what actually had you done over here? You had put this point. So this point, it satisfies this inequality. This point 0, 0, it satisfies this inequality. So that is why the region will be pointing towards this side. So since I'm using a black pen, that is why I will use a black pen for this. So this whole side, okay, it will be the region represented by this first inequality. Okay, now let us take a look at the second inequality, x1 minus 3x2 equal to 0. So over here, you notice that the right hand side is 0. If the right hand side is 0, just take any other point, okay, which is not on the line. So we can take x1 equal 1 and x2 equal 1. So when you put x1 equal 1 and x2 equal to 1, okay, I am actually doing it for the second one, so let me write it with a red pen. x1 equal 1 and x2 equal to 1. And you are concentrating on this line now, x1 minus 3, x2 equal to 0. So if you put x1 equal 1 and x2 equal 1 on this side, you will be getting 1 minus 3 greater than or equal to 0, which is, that is why it is not satisfied. So what you actually did, you were taking this point, x1 equal 1 and x2 equal to 1, which is this point. So this inequality, it won't be satisfied. So that is why the region will be the side opposite to it. Okay, so this line, we are concentrating on this line. This point, it won't be satisfied. So that's why the region will be pointing this side now. So for the second line, we are having this region. Okay, so everything to this side will be the region represented by this inequality. Now let us take a look at the third region, the third inequality, which is this one. Again, the right hand side, it's not equal to 0. So let us put x1 equal to 0 and x2 equal to 0. You don't actually write this one, but I'm just showing it. So if you substitute it over here, you will be getting 0 less than or equal to 6, which is satisfied. Okay, it is satisfied because indeed 0 is less than 6. Over here it's not satisfied because this is not true. Okay, so you were taking the point 0, 0 and you were concentrating on this line. Okay, the blue line, x1 by 3 plus x2 by 2 equal 1. So this point is satisfied, so that's why the region will be pointing here. Okay, so if you take a look at all of this, okay, and you remember that we are dealing only with the first quadrant because of these conditions. So the feasible region, if it has to exist, sometimes it may not exist. Okay, if it has to exist, it will be in the first quadrant. And how actually do we find the feasible region? Okay, you can see that there is a region which is shaded blue, shaded black, and shaded red all at the same time in the first quadrant, which is actually this portion here. So this portion, it is shaded black. It's also shaded red and also shaded blue at the same time, and it is in the first quadrant. So that's why this region, okay, let us call it, okay, this region here, it is shaded black, blue and red all at the same time. So that is why this one will be the feasible region. Okay, call it OAB or OAP. P is this point of intersection of this line and this line. So OAPA is the feasible region. You have to be careful that if there is no common portion, in that quadrant, then you can easily say that there is no feasible region. Okay, but over here we are lucky that indeed there is a feasible region. Until next time.